NASA finally reveals Soviet Union landed on Mars. Amidst the mysteries of our universe, NASA unveils a revelation that defies history. The Soviet Union landed on Mars, they finally admit. Join us as we embark on this cosmic journey, unearthing secrets that rewrite the books of space exploration. The Cold War, marked by its intense ideological and political rivalry between the United States and the Soviet Union, gave rise to a technological race that propelled humanity toward the stars. Within this epoch, the space race emerged as a vital component, exemplifying geopolitical competition and ushering in an extraordinary era of scientific and technological breakthroughs. However, amidst these remarkable achievements, there were moments of profound setbacks and humiliations that the United States endured. The seemingly invincible Soviet Union appeared to gain the upper hand in the race, casting a shadow over American aspirations. From the shock of Sputnik's launch to Yuri Gagarin's historic space flight and the tragic Apollo 1 command module fire, the U.S. encountered a series of disappointments. Yet, the path to the moon was far from paved with resounding successes and unrestrained jubilation. With unwavering perseverance and dedication, the U.S. saw the triumphant success of Apollo 11, an event met with overwhelming enthusiasm and a live television broadcast that captivated 500 million viewers worldwide. However, beneath the surface, Soviet scientists had been quietly toiling away on a highly classified project that could have surpassed the significance of a lunar landing. Their ultimate objective: to send a human to Mars. A goal that, had it been accomplished, would have predated the aspirations held today by figures like Elon Musk by nearly half a century. So the question arises, what were the origins of these groundbreaking plans, and why did it take several decades before the world knew about these missions? The core of the matter can be summarized thus: admitting mistakes is not something anyone appreciates. This was especially true for a superpower facing intense scrutiny during the Cold War, burdened with casualties and rumors of fake satellites. As history tells us, the Cold War era witnessed relentless competition between the United States and the Soviet Union, each striving to assert its superiority in various domains. This fierce rivalry extended far beyond the bloody proxy conflicts in Korea, Vietnam, and Afghanistan, seeping into nearly every aspect of politics, economics, and technology. Given this background, it becomes understandable why the Soviet Union, when faced with setbacks and failures, chose to skillfully ignore or conceal them. Evidence reveals that as far back as October 1960, about 9 years before the renowned Apollo 11 mission, Soviet scientists and engineers had already redirected their focus toward Mars, reaching beyond the moon as their exploration target. In the early 1960s, the Soviet Union launched missions to explore Mars, marking a significant milestone with pioneering contributions that paved the way for future expeditions to this enigmatic red planet. Mars, as the scientific community understands it, is the only planet in the solar system that closely resembles Earth, with similarities in rotation period and axial tilt, as well as evidence suggesting it may have hosted vegetation and water in its past, adding to its intriguing ambiance. For the Soviets, the Mars program comprised a collection of unmanned spacecraft missions aimed at investigating the Martian environment. The Soviet Union's first Mars mission, Mars 1, commenced on November 1st, 1962, lifting off from the Baikonur Cosmodrome in Kazakhstan. This spacecraft, propelled into space by the Molniya 8 K-78 rocket, was an automatic interplanetary station with the primary objective of conducting a flyby of Mars, thus becoming the first nation to reach the red planet. The mission aimed to collect essential data about interplanetary space between Earth and Mars, explore Mars's magnetic field, and detect any magnetic field in its environment. Additionally, Mars 1 was expected to capture images and gather valuable scientific data about the planet and its atmosphere. Equipped with a cylindrical body, 2 solar panel wings, and several antennae, Mars 1 was ingeniously designed to guarantee uninterrupted communication with Earth throughout the mission. It featured various instruments, including a magnetometer, detectors for meteoroids and cosmic rays, and a plasma ion trap for the study of solar plasma, among other advanced tools of that era. Furthermore, Mars 1 possessed a dedicated radio system for transmitting photographic images back to Earth. However, a significant setback occurred on March 21, 1963, halfway through the spacecraft's journey toward Mars. Communication with Mars 1 suddenly ceased, leaving mission control in the Soviet Union, unable to communicate with or control the spacecraft. Investee. However, a significant setback occurred on March 21, 1963, halfway through the spacecraft's journey toward Mars. Communication with Mars 1 suddenly ceased, leaving mission control in the Soviet Union, unable to communicate with or control the spacecraft. Investigation revealed a malfunction in the spacecraft's orientation sensors, leading to excessive power consumption by onboard systems and ultimately resulting in a total power loss. Despite this setback and subsequent failures, such as the destruction of Mars 2M spacecraft during launch by 1971, the Soviet Union's early exploration of Mars marked a significant step in humanity's quest to explore the cosmos. But how did the Soviet officials navigate the intricacies of secrecy and setback? In the midst of this cosmic chess game, where the Mars program faced countless hurdles, from communication failures to missed landings, what were the untold stories of those who strived to conquer the enigmatic red planet? For years, Mars remained an elusive goal, shrouded in mystery. The Soviets carefully guarded their mission details, revealing only successful launches, while leaving the world to wonder about their progress. Decades passed, and space enthusiasts and experts alike pondered the fate of those missions that seemed to vanish into the Martian ether. Then, in 2007, a glimmer of hope emerged as U.S. researchers released a high-resolution image of Mars, reigniting interest in the lost missions. In 2011, a passionate space enthusiast claimed to have spotted light-colored debris resembling the Mars 3 parachute, sparking a renewed quest for remnants of the mission. Despite these tantalizing leads, the small rover's whereabouts continue to elude us. Yet the Mars 3 mission, despite its limited scope and challenges, provided invaluable lessons that paved the way for subsequent missions and enhanced our understanding of the complexities of reaching and exploring the red planet. As we stand on the brink of a new era of Mars exploration, with the allure of uncovering extraterrestrial life and unraveling the planet's geological and climatic history, the legacy of the Soviet Mars program remains a testament to the resilience of human endeavor. NASA's upcoming missions, like the Mars Sample Return (MESAR) mission, promise to chart new territory in interplanetary research, pushing the boundaries of technological advancement and human space exploration. The MESAR mission, a collaborative effort between NASA and the European Space Agency, ESA, represents a monumental undertaking in the history of planetary exploration. It builds upon the groundwork laid by the Mars 2020 Perseverance rover, a car-sized marvel designed to explore the Jezero crater, an ancient river delta site on Mars. Equipped with a sophisticated array of scientific instruments, Perseverance's primary mission is to delve into the region's geology and climate. What sets it apart is its ability to identify and gather rock and soil samples that may hold evidence of past microbial life. These precious samples are carefully stored on the Martian surface for future retrieval. The next step involves launching a sample retrieval lander to Mars, incorporating a small ESA-provided rover tasked with retrieving the stored samples. Once acquired, the rover will transport these samples back to the lander, where they will be placed into a Mars ascent vehicle, a small rocket that will launch them into Mars's orbit. But the journey doesn't end there. An Earth return orbiter, the third component of this mission, will capture the sample-filled canister and initiate its journey back to our planet. Upon reaching Earth, the canister will be safely landed, granting scientists worldwide direct access to Martian material for in-depth analysis. In well-equipped Earth-based laboratories, these Martian samples can be studied with advanced techniques beyond the capabilities of even the most sophisticated remote instruments on Mars rovers. The wealth of data from these analyses will yield invaluable insights into Mars's historical and present conditions, its geological evolution, and the tantalizing possibility of past life on the red planet. The Mars Sample Return mission marks a transformative phase in our quest to decipher the secrets of our neighboring celestial body. While the Soviet Mars program may have been marked as one of the most notable failures in the history of spaceflight, it undeniably laid a firm groundwork for future Mars exploration endeavors.